Please make sure that if you have not done so already, that you really did read the handout that goes with solving three-dimensional systems of equations and their types of solutions. The handout is posted on gilpinschool.net. I also do have handouts available in class in your guys' bin. As you have already seen when you worked through the worksheets for Objective 3 and Objective 4, you know what it looks like when you get a no solution system. Remember, a no solution system is when you get something funky. 2 equals 5, 0 equals 7, negative 4 equals 3. Something that's never true is no solution. We've looked at that type of situation before. Looking at what happens when we get a dependent system. So dependent system is going to be with infinitely many. So remember, that's going to be when your three planes intersect on a line or when your three planes lie on top of one another. What does that look like? So I'm going to go ahead and do this example. I am going to adjust this a little bit. I realized that when I typed this in, I typed it wrong, and rather than go back and re-upload everything, all I'm going to ask you to do is change this first equation to be 3x, it's kind of sloppy, to be 3x minus 2y plus z equals negative 1. So my equation 1 is going to change. Now I'm going to go ahead and I can either use substitution or elimination. I'm just solving a system of 3 dimension. I'm going to enable them 1, 2, and 3. And I notice that 1 and 2 are already set up very nicely to make my z's eliminate. And number 3 already has z eliminated. So I'm going to go ahead and use elimination. I'm going to add equations 1 and 2 together. So I'll have 3x minus 2y plus z equals negative 1. Again, I changed equation 1. And I'm going to add to that equation 2, 2x plus y minus z equals 5. Adding those, I get 5x minus y. My z's go away, equals 4. I'm going to call that equation 4. Typically with elimination, I have to pick or pair two other equations to add together, but since equation 3 already has the z gone, I'm going to go ahead and call equation 3 equation 5. And here are my two equations that I'm now going to use the same techniques I learned in Algebra 1 to solve. Well, I learned back in Algebra 1 that if I had the exact same line, that meant right there that the same equation meant I had infinitely many solutions. So from here, I can already see that I'm going to have infinitely many. Let's say, though, that you weren't able to see that and you said, oh, I'm going to solve equations 4 and 5 with elimination. So let's say you said, I can get opposite x values if I multiplied equation 5 by negative 1. And then I would have 5x minus y equals 4, leaving equation 4 alone. Equation 5 would become negative 5x plus y equals negative 4. Adding negative 5x plus 5x is 0. Negative y plus y is 0. I can't just have empty space, so I have to fill it with something, so 0. 4 plus negative 4 is 0. 0 equals 0. I ask myself, when does it happen? That's a statement that's always true. Therefore, I can say infinitely many. So again, notice I've determined there are infinitely many solutions to this equation. I do want to point out, especially if you're someone who's understanding this material, we can take this a step further. I'm not going to necessarily require it in Algebra 2, but just to point out, so if you feel like you're understanding this, hang tight and finish watching this video. What I could do with this information is I could say, I'm going to solve my equation up here, whether it's 4 or 5, doesn't matter, they're the same, for my y value. Well, if I solve this for y, I could add y to both sides. And let me see, I'm going to change color since this is kind of some bonus material. So if I add y to both sides, I get 5x equals 4 plus y. Subtract 4, I get 5x minus 4 equals y. Okay, so now if I'm given some arbitrary x value, I know what y is going to be in relation to x. If I do the same thing to solve for z, I can go back up to my equation. Let's say I have to pick either equation 1 or equation 2, because if I'm going to try to solve for z, equation 3 doesn't have a z variable. So there's no way if I plug in for equation 3 that I'm going to come up with what z is. So let's say I plug into equation 2, since I can see that on my screen from here. Then I would have 2x, and instead of writing y, I'm going to say plus 5x minus 4. Typically, it would need parentheses, but I can already see that I'm not going to have anything to distribute. Minus z equals 5. So I'm going to add z. I'm going to add my x's. So I get 7x minus 4. I'm also going to subtract my 5 from both sides and add z to both sides. So that tells me, cleaning up a little bit, that 7x minus 9 equals z. So I'm going to get infinitely many solutions for this system, as I already found out, but I can tell that every single point is going to have the relationship that if I pick some arbitrary x, my y value is going to be 5 times x minus 4. My z value is going to be 7 times x minus 9. So even though I know that there's going to be tons and tons and tons of solutions out there, I can also go a little bit further and say all of my solutions are going to take this form. So like I said, just taking that learning, that extension piece a little bit further.